Hello students, this is a Unit 7 review, Water on Earth. Here are the objectives for this unit. For this unit, you want to make sure that you can explain the hydrologic cycle. That is just the water cycle, so make sure that you know all the different parts. Make sure that you know those vocabulary words that go along with the water cycle in this unit. Also explain how the gravitational interaction of the Earth, Moon, and Sun causes tides. This one is really important, so you want to make sure that you understand this. This is one that really confuses students on the assessment, so we want to make sure that we go over this. So we have our daily cycle of tides. There's 2 high tides and 2 low tides each day. But then we have our monthly cycle, so you want to make sure that you know that. You want to make sure you know what a spring tide is and what a neap tide is. So during a spring tide, the gravitational pull of the moon, and this is just showing that the moon can be in either the new moon or the full moon position. So you can kind of ignore one of those. But if the moon, the earth, and the sun are all in a straight line to one another, then you're going to have a spring tide. This is because not only do you have the moon's gravitational pulls on that side of the earth, the water on that side of the earth, as well as the opposite side. So you have the moon pulling in one direction, and then you have the sun pulling in that same direction. Therefore, the water here is going to be at its very highest. The water on the 2 opposite sides are going to be at the very lowest. So when we have a spring tide, when the earth, moon, and sun are in a straight line, we have the highest high tide that there is and the lowest low tide because there's not as much water left over here. So as the earth rotates, we have 2 of our highest high tides and 2 of our lowest low tides. Whereas during a neap tide, then we have the earth, the moon, and the sun creating a right angle to one another. So now we have the earth, the moon pulling in one direction and the sun pulling in the other. So now all the water is kind of being distributed a little bit more evenly, and now our high tide is not quite as high as it was. So we have our lowest high tide of the month and our highest low tide because we have more water being pulled to that low side. That's the wording that kind of gets students. So during a neap tide, when they're at a right angle, the earth, moon, and sun are at a right angle, we have our lowest high tide and our highest low tide. Hopefully that explains those a little bit. If you have more questions on tides, let me know. Some other things that you want to make sure that you know, recognize that radiation from the sun warms the upper layer of ocean water, but it can't penetrate to great depth. So this results in 2 very distinct layers of warm and cold water separated by that boundary known as thermocline. So make sure you know that definition. Also make sure you know how wind blowing on ocean water results in waves and surface currents. So wind creates our surface currents. Our deep currents are created by the differences in temperature and salinity in our ocean water. And we'll go over that a little bit more right here. So recognize factors influencing salinity of ocean water. So we want to make sure we know. The colder the water is, the more dense it is. The warmer it is, the less dense. And then we have salinity. Obviously, the more salt that you have in the water, the more dense it's going to be. The less salt, the less dense. So cold water that has a high salinity is going to be the most dense. No different things that influence this. So for instance, where you have a river emptying into the ocean, this would decrease the salinity of your water because you're adding fresh water. So anytime you add fresh water to the ocean, your salinity is decreasing. Anytime you take fresh water out, your salinity is increasing. So where is an example of fresh water being removed from the ocean? That would be near the equator where you have a lot of evaporation. Okay. At the poles where you have the water freezing into ice caps or glaciers, that's going to increase the salinity. If a glacier melts, that's going to add fresh water to the ocean. That would decrease your salinity. So make sure you know different examples of what would increase or decrease your salinity. If you have any questions on that, let me know as well. A couple other things you're going to want to know is you want to make sure that you know the definition of an upwelling as well as a downwelling. So an upwelling is where you have your warm surface water is blown out to sea by your winds. There's nothing to replace that, so it's going to pull up that cold, nutrient-rich water. That's an upwelling. So if you've ever been swimming in the ocean and you hit a really cold spot, that might be an upwelling. So make sure you know those definitions. All right, and then the last thing, we just talked about our upwelling, is make sure you know what creates larger waves and stronger winds. So strong winds that blow for a longer time are going to create rougher water. This is because the stronger the wind is, the more energy it's transferring to the water. The longer it blows, the more time it has to transfer that energy. So strong winds and winds that blow for a longer time are going to create bigger waves or rougher water. All right, if you have any questions on Unit 7, let me know. Otherwise, good luck on your assessment.